right. So today we are starting laser unit. So first of all, let's see the meaning of laser. So the first letter L. L is stands for light. So this is L is for light. A for amplification. Amplification. This is amplification. And S is for stimulated. Stimulated. This is the stimulated. And E for emission. Emission of. R is for radiation. Radiation. So the full form is the light amplification, stimulated emission of radiation. This is for your knowledge. And next we'll see the characteristics of laser. So which means that how a laser is differ from a normal light. So that we are dealing in our day-to-day life. Okay, how what is the speciality of laser in short? So that we're going to study. So first of all, so the left side that we have is, let's say, laser, and on the right side that we have is the normal light. Okay, so as you have seen the laser, okay, so you must have seen in your childhood maybe, so how it looks like this. Let's say this is a laser, okay, and laser, so you must have seen this. So this way light comes out in a particular direction. Now this is for the laser, okay, and let's talk about a normal light. Let's take an example of a torch. Okay, so let's say this is a torch, normal torch. So how does it differ? So this is something that you already know. Okay, so which means the torch, it spread lights like this way it spread light. So this is a laser, and this is a, let's say, a torch, a normal torch. This is a torch. Now the major difference is that it's the first difference is that the coherence, okay, or you can say that the laser is coherent. Coherent. So what does it mean, coherent? Which means coherent, which means that the light, as we know that the light has a wave nature, okay. So the light has a wave nature and it's a wave. So let's say that it consists of so many waves. For example, here we are considering about the red laser, okay. So red laser has a wavelength, but whatever the wavelength coming out of this laser, okay, so all will be in same phase. All will be in same phase, which means let's say like this. This is a one wave. It will be like this, light wave. So which means though whatever another light which is coming from the laser, okay, so that will be in the same phase, and they have the same oscillation or same part difference. Everything will be same. Sorry, this is not that sharp, but you can understand. But in terms of the normal light, so normal light, not two, this is the one. So normal light is the non-coherent. Non-coherent. Non-coherent, which means, see, this is a white light, okay, normal light. So normal light is consists of the seven color, and as we know that all seven color has a different wavelength, okay. So different wavelength has what does that mean? Which means their wavelength will be different for the different color. So red, yellow, green, orange, blue, so all will have a different wavelength. So their part difference will also be different, like this. For example, let's say this is for red, so for different colors it will be like this, nor it will not be same. Okay, so that is nothing but coherent source. Now the second difference is the uh, this is a monochromatic. This is a monochromatic. So monochromatic, which means it contains only single wavelength, single color, or single wavelength. Wavelength, which means if we are talking about the red laser, so it consists or it emits only a red color, or green. If we have a green laser, so it will emit only uh, green light. But no, not in case of the normal light. So this is polychromatic. So you can say that polychromatic light, which means it consists of seven colors. Okay, or there will be more than one color. And yes, the third one is the, as you can see from the diagram, it's a directional. It's a directional. You can say DIRE, directional. So what does it mean, directional? So directional, which means, so as you can see, laser only travels in a single direction. It's like a pointer. Okay, so it will not spread or it will not diverge. But as you can see from the normal light, so normal light is a non-directional. Non-directional. So which means non-directional, which means as you can see, it's red. Okay, so the light. So whenever we turn on the torch, so what will happen? So its light will be spread like this. Okay, so this is the third difference, and the fourth one, which is the most important, and that is the high intensity. So laser is high intensity, and this is obviously it's a low intensity. See, due to this high directionality, which means the all the light which is in the same direction. Okay, so that makes it a high intensity, or highly intensive. So that's why this is used in usually in eye surgery, or in so many industrial applications, rather than this the normal light. Okay, so as we can see, the normal light is why this is a low intensity, because it's spread. Okay, this is not focused. See, the light is not focused in a particular direction, it's diverts. So that's why this is low intensity. So this is the characteristic of laser, so which is for a little bit of your knowledge. Now let's talk about the other topic, that is electronic configuration and energy levels. So you should understand this before understanding the laser. Okay, so what do you mean by electronic configuration and the energy levels? Okay, so you must have heard the words atom. Okay, so let's see. So suppose, let's say we have a container like this. Okay, and in that container we filled a gas. Let's say this is a container, it's a box, and we have filled like this. This is a gas. Okay, so let's say that this, let's name this gas is the helium gas. This is let's say helium gas. Okay, so now what I mean by this, that what we are interested in this the atom. As you can see, the dots, these are nothing but the helium atom. So how does this atom looks like? Okay, so the atom, that individual atom. So we will going to, I'm going to draw this separately so you can understand. Let's take a one example. If I draw, if I represent this tiny atom, okay. So if I want to represent this, so I'll represent it in this way. I'm just representing this. So how does this tiny atom looks like? Okay, so we will see that at the atomic level or its electronic configuration and its energy levels. So as we know that the atom is, let's say, let me take another color. So let's say this one. Okay, so let's take the red one. So at the center, let's say, as we know that the atom has a positive charge. This is a positive charge, or you can say the nucleus at the center. Okay, this, sorry, nucleus, it's a positive charge, or you can say this is the nucleus at the center, and it has electrons revolving around the nucleus, which means it has like this orbit. So here, for the simplicity, I'm just introducing two electronic orbit. You can say two orbit only. So these are nothing but the orbit. So this is called an orbit. So let's say that this is the positive charge, this is the nucleus, and the electrons are revolving around this orbit. So these are called orbit. Orbit. Okay, this is the first and this is the second orbit, which means that the electrons, so let's say, let's represent the electrons. So let's say this is one electron, this is the second electron. So these two electrons are revolving around this nucleus. They are revolving, and the outer layer, let's say there are four electrons. This is for understanding only. Okay, so let's say one, two, three, and four. Now you have to keep one thing in your mind is that here I have represented only the two orbit. So that doesn't mean that the all atom contains only a two orbit. Okay, there are more than two orbit. So depending upon the which gas you are using or which type of material you are talking about. So that depends on the material. Okay, here for example, I've taken helium gas, so it can be nitrogen, oxygen, it can be anything. Okay, so there will be a number of electrons as well. Okay, that doesn't mean that in the first orbit there will be only two electrons, or in the second orbit there will be only four electrons. It's nothing like that. Okay, so this is just for understanding. Okay, so here the first thing is that the first orbit, as you can say, which is very close to the nucleus, this is the nucleus, this is the positive. Okay, so this is called the ground state. You can say that this is the E1, or this is the first energy state, or this is also called as the E1. Okay, so E1 is you can say that this is the ground state, and we are assuming that this the outer orbit, or you can say the second orbit, is the E2. E2. So E2 is nothing but your excited state. Okay, so your E2 is the excited state. So now in your upcoming theories, so we will not going to represent this electronic configuration and energy levels in this form. Okay, we will not going to represent in this form, but instead of this we will going to represent it like this. So you have to remember this. So let me draw that. So we will going to represent these two orbit. Okay, so like this, like a level. Okay, which means, as you can see, so these, this is the first thing, you can say this is the E1 and this is E2. Okay, so the E1 is nothing but ground state. So that this is ground state and this is an excited state. Excited state. Now again I'm repeating this word that here you can see we have only two orbit. Okay, so as I said that there will be number of orbits are there depending upon the which gas you are talking about. Okay, so which means if there are number of orbits, which means there will be number of excited states. Again I'm repeating. Okay, so don't think that there is only one ground state and there is only one excited state. Okay, so yeah, the thing that you have to remember is the ground state will only one, that is very close to the nucleus, but there will be you can say one or two or maybe more than two excited state. Okay, that we're going to see when it comes in the theory. So this is an excited state. Now as you can see, so we have this electron. So let's say that in the first orbit, this is the first orbit. Okay, so E1. So as you can see, we have only two electrons. So we are representing like this. Let's say like this dot. Let's say this one. Let's say this way. So this is one and two. Okay, as you can see, and in your E2, so this is in a excited state. So excited state that we have the or you can say the second orbit that we have four electrons. So let's say this is one, two, three, and four electron. Okay, so now there is a representation of this electrons, and if we in laser see how many electrons are there in the ground state, that is matter. Okay, so how many electrons, so by mean that we have to understand, we have to have some representation and we have to represent the quantity, that how many electrons are there in the ground state. Okay, so we will introduce a word. Let's say, let me take another color. Okay, so let's say that we will represent these things. Okay, whatever. So for example, here we have only two electron in the ground state. So this I'm talking about this one. Okay, so here for right now that we have only two electrons, so we can say that this n1, this is nothing but n1. So n1, which means that is the number of electrons in the ground state. Ground state. So for example, see here you can see that we have only two electrons, so we can say that n1 is equal to 2. Let's say n1 is equal to 2. This is again for understanding only. Okay, so this is for n1. So now as you can see, this is the n2, right? So let's say that this is n2. N2, which means the how many electrons that we have in the excited state. As you can see, this is the 4 electron. So here again, your n2 is the number of electron in the excited state. So these are the key points that you have to remember. Now this box you are seeing, that the helium gas, this is in a normal condition. Okay, or you can say the atoms, so these are nothing but atoms. These are all are helium atoms. Helium atoms. So what does it mean that all the atoms, as you can see, so we haven't done any process. Okay, haven't done any process, which means the helium is at the ground state, or your helium atom, all the helium atoms are at the steady state, which means we haven't done anything, like we are not exciting it. Okay, this is the key point that you have to remember. So all the electrons, see, in the first orbit, the two electrons are revolving, and in the second orbit, the four electrons are revolving. Okay, so they will keep on revolving around the nucleus in a particular orbit. Okay, so now this is it for today, and we will see uh, the transition, uh, or we'll study about detail of laser, that how laser produces. So we will see that in your next video.